All right, Shivam, see ya. Welcome back for a 3-mix. Yeah, third time. I ran out of room and time and focus on the last one, so we're going to do it again. This has been a very wasteful day, but I've enjoyed it so far. Let's do this hard problem. The weird thing about this problem is A is significantly harder than B. So let's start with A, because it's part A. We are going 100 revolutions in 1 minute. That's what RPM means. And it's okay if you don't understand that. And then they want to know what length radius will make the tip of this sling travel at 40 meters per second. So actually this is an equation. And on this, just always include your units. So we got revolutions per minute, we got meters per second, and we're looking to solve for radius. Well, we can't solve for it until we get both the left side and the right side to have the same units. So let's go that 1 minute has 60 seconds. And now we're in revolutions per second. We need to get to meters. Well, how are we going to get to meters? Oh, well, how about this? If you do 1 revolution, that's 2 pi r meters, because that's the circumference. So 1 revolution is 2 times pi times r. Well, hold on, let me change colors on that r. That r is going to be our variable. Meters. Okay, all right. So look, now over here we have meters per second. Over on the right side we have meters per second. So now we can set up an equation. 100 times 2 pi r over 60 equals 40. I just grabbed all the numbers and I didn't multiply anything by 1. You know, I eliminated the ones. So then what you have from that is 200 pi r is 240. Pi r is 12. So r is 12 over pi which is 3.82 meters. What does that mean? It means if you take a rope and it's a 3.2 meter rope, so that's pretty big, like that's a huge lasso, that's almost like a helicopter, and you spin it around at 100 revolutions per minute, that thing is going 3.82, I'm sorry, it's going 40 meters per second. Okay, now part B says if the sling is just 1 meter long, how fast will it be going? So this, look, if the radius is smaller, it's going to be going slower. This is such an important part of sports. The reason the driver hits it further is that the driver is the longest club. Now, I know there's other reasons, but in essence, that is the most important reason. The longer the radius, the faster the head speed. So, we're going 100 revolutions per minute, and we want to know how fast is that in meters per second. Okay, we can do that. So let's get rid of minutes. 1 minute has 60 seconds. So now we're in seconds. Now let's get revolutions into meters. Okay, well, 1 revolution goes 2 times pi times the radius. Well, our radius is 1, and that's how many meters it goes in each revolution. And now that's going to end us with meters per second. And I bet it's about 1/4 as fast as it was at first. If this one was going 40 meters per second, I bet the answer to this one will be just maybe around 10 meters per second. Well, it's going to be 100 times 2 pi divided by 60. I'm kind of anxious to see what the answer is. 100 times 2 pi, enter, divided by 60. Uh-oh. Got him! Boom!